Aerodrome will just revert our transaction because the deadline has passed. So let's come here now, and this amount out minimum. It's the same concept with what we did here, but just in a different way. I'm going to come here now, and you'll see how we are going to implement it. All right. Now, again, we are going to call a function called get amount out aerodrome v2. I'm just going to comment it out for now. I want you to pay attention here. Here we call chainlink to get the price in Unisolve v3. In the case of aerodrome v2, it has this function get amount out that simulates our swap and tells us the probable amount we are going to get from whatever we want to swap, the amounts we want to swap. So we can simulate our transaction before we do it. So that's how we are going to get the amount out minimum. So let's define this function now. Over here. Down here, yes. So I'm just going to come down here. Okay, let me uncomment this. I'm going to come down here and define the function. Now it's also a public view returns. Now this view keyword is important. Anytime you are defining a function that is not making state changes, so it's just reading the value of variables in the contract and returning it. So it's not changing the state of any value. Then you put view there. All right. So that's it. You will notice that some of the functions have that. The same thing for this too, because we are just reading the values on the blockchain. All right. So what do? What we have here is we are calling get amount out on this contract. We pass in the amounts we want to swap and the routes, the struct routes. Yeah, we'll pass it in, and it's going to return this array. It's an array of amounts, but we are interested in the value in position 1 of the array. All right. So it's going to return that. Now, based on that, we will now use our slippage tolerance to calculate the amount out minimum we are willing to take. Don't forget we've set this to be 0, but if you are going on mainnet, make sure it's something around 1%, 5% slippage you're using. Now we have the duration missing. Let me go up because that will help us for our deadline. I'm going to come here and I'm going to set it to 15 seconds. It's constant. Now, constants are quite cheap to store on the blockchain because they are not included in the storage slots. They are included in the byte code of this contract itself. Every time you write on the block inside the storage, inside the memory of in the blockchain, it costs 20,000 gas. So if there is no need for you to write in the storage, it's a good practice to avoid that. So this is a constant and it's 15 seconds. As before, we need to expose this internal function. So here is external function that calls this internal function. All right, and the first thing it does is whoever calls this function will have this amount, this specified amount of token in taken from him, and it will be transferred from him to this contract, our contract. Then our contract will now swap it on Aerodrome v2 and keep it on the contract. All right. Now, when we start interacting with this contract after deploying it, you'll see how this safe transfer from works, because whoever is calling this function must have approved our contract to take this amount of token from him. So you'd see that later. All right. So at this point, we can say that we have completed number 3. So we've been able to implement swap function on Aerodrome v2. I'm going to now add functionalities to withdraw tokens from the contract and to also withdraw ether. I'm just going to come down here. I'm going to implement them here. All right. So the first one is emergency withdrawal. This is to withdraw any ERC20 token in the contract. Only owner, only whoever owns this contract, and in this case, it will be the deployer of this contract, can call this function. Require statement is another way to test condition in Solidity. We've used if statements before. Up here, if I can just find that, I think easily I can just find it like this. Yes, so you can see if statements and we revert error. In this case, we are using require. So it requires that this condition is true, otherwise it will revert this error. So it's going to test the address. Okay, I should be here. It's going to test the address recipient to be a valid address. Is not a zero address. If it is not a zero address, then it will transfer token, the specified token, to the specified address, and it will be this amount. If it is a zero address, it will tell us it's invalid. Right? So that's what this one does. What this one does is for us to withdraw ether. Ether is a coin. Other ERC20 are tokens. All right. So tokens are also smart contracts, but ether is a coin. It's the native coin of Ethereum blockchain, and so that's the coin in which you pay gas fees. That's why it's the native coin. Now, what it does, the first thing is to check that is we have a valid recipient address here. Then this is how we use this low-level call to call our contracts, and any ether stock in this contract is transferred to the address we have specified. All right. Then we require that after this line, it returns a success or failure response to us. We require that this is true, otherwise it will tell us this error. So before we compile, let's quickly restrict over here. Yes, only whitelisted. I'm going to use it to restrict those that can call these our swap functions. All right. So I'm going to put only whitelisted here. Then over here too, I'm going to include it here. Now, all right. So only those that we allow can call these two functions. But don't forget that multi-call handler, the second contract on a cross pool, would be calling when we send our message here. We'll be calling this function. So we need to whitelist the address up here. The first thing is we have to pass the address in here, the address of the multi-call handler here, and so as we whitelisted our own address here, that's the address of the deployer of this contract. So the same way, instead of msg.sender, it will be the address of the multi-call handler contract. So we've set it to true. We've whitelisted it, so it can call this contract. It can call these functions now. So now let's now compile. That was a mistake. So with Command J, you can bring up the terminal, and as before, we are going to run forge build to compile the contracts. All right, everything seems to work. It's just giving us suggestion regarding how else we can write only whitelisted modifier, but I think I'm just going to ignore that. So the next thing now is I'm going to write deploy script. So this is where it's going to be in. So I'm just going to come here. I'm going to write right click. I right clicked. Let me do that again. Right clicked on script. I'm going to select file. So it creates a new file for me, and I'm going to name that file deploy base to other chain. I'm just getting the exact name of the contract here. Color .s.so. This is how you write a script in Foundry. So we can get started with the deploy script. Before we get started, I'm currently creating a 12 to 24 weeks training course on smart contract development, auditing, and blockchain decentralized application automation. It's going to be a comprehensive training course, and mainly it will be a one-on-one section. I'm not taking more than 10 students at a time, and so that I can take you from any level you are in, whether you have written code before or you've never written any code before, and make you into an expert. If you are interested in this training course, please leave your comments below, and once my waiting list page is ready, of course, I'll let you guys know. If you want to integrate blockchain solutions into your business, or you have an idea of a blockchain application and you want me to write that for you, or you just want me to audit your code and take a look at your code base for you, please check the description to this video, book a call directly with me, and I'll take it from there. Let's start as usual. For us to write a script, the first thing is, as normal, we need to define the license, then the solidity version we'll be using. Now, this is quite important. Scripts, we are going to import it from the standard Forge library. This is our contract that we are going to deploy. I'm going to come down here and declare this. So this is our script. Let me be sure that it's exactly the same name with our file. So copying it, come here to rename it. But .s means that we are declaring a script. So you can see we are inheriting the script library. That will ensure that all the properties in this script is going to make it available for us to use in our deploy scripts down here. So over here, we are going to write a function called run. Now this function run will always be called every time we deploy this. We call this script. So it's inside this run we are going to deploy our contracts. I've just included vm.start broadcast and stop broadcast. Now, whenever Foundry see vm.start broadcast, what it does is it starts running the blockchain in the background, and it's going to give us 10 dummy accounts, wallets. The first of the 10 dummy wallets is what is going to use to deploy our contract for us. You'll see how that works when we start testing. So for us to deploy, we'll have to start broadcast and end it. It's inside here. We are going to define our contract. We've already imported it, so I'm going to define it here. So this is our contract. We make an instance of it. So here, so new base to other chains contract. Now it's showing error here because when we come back to our contract, there are 3 things we need to supply. Our constructor takes these 3 things. So I'm just going to copy these 3 addresses across Spoke, Multicolor, and Uniswap v3 router. So I'm going to come back here. I'm going to just comment them out for now. So we need to supply the actual value of these 3 parameters. Yes, as parameter into this when we are deploying it. So let's try and get them. I'm going to come here and create a file called helper config.s.so. This is where we are going to keep all our values, all our constants. so we can easily import it into the other scripts. So as before, we define the license solidity version. Okay, let me just make this anything greater than any version greater than 0.8.0. I've imported the script. Then I need to import. Let me delete this. We'll still get to this later. All right. So this is where we are going to put all the values. We'll come inside here now, and the contract addresses we needed. I showed you in the beginning the documentation of across protocol. So from there, we get this contract address for across spoke on base Sepolia testnet. Because we are still working with base Sepolia side of things. This is the address of the multi-core contract on base Sepolia and Uniswap v3 router on base Sepolia. Again, I'm going to leave the link to the documentation of Uniswap v3. So there are many contract addresses on Uniswap v3 documentation. Make sure you get the one for swap router 02. That's it. So we have this. Now we are going to import this lpath config into our deployer here, the deploy script from. I am going to have now dot means the current directory, and that's where you'll find this file. So what we've just we put semicolon at the end. So what we've just said is check this current folder and you'll find this file there. So that's what we've done. So now that we have this, let me include a constructor here because we still have a lot of things to write inside here. Now we can come here and make an instance of our config file, config file, which is this. Now that makes all those values available to us. So the first thing is we need a cross spoke address. This, so let me come here and see this is a cross spoke. That's the first one. You need to come back here now in the deploy script and define it. All right. The next one is, again, we have our epath config. It's the multi-handler address. Let me come back here and get that. That with this file we've created, all our constants will be here, and it will make a whole lot of things easier for us. So this is for the Uniswap router. I need to state that I'm getting it from the epoch config and put bracket. Okay. The funny thing is I've defined all of this outside here. It's meant to be inside here. So I was just wondering why we were getting error. All right. So yeah, our deploy script seems to be ready. All right. So let's see. Let's try and run this contract and see how far we've gone. Let's see if it still compiles. So I'm going to run forge build. Oh, it still runs. This suggestion, I don't like it. Maybe I'll just take it so that I stop seeing anything red here. But it has compiled. All right, so I'm just going to copy this, then replace our modifier here. All right, okay. This unnecessary plus sign, I'm just going to get rid of them all. Okay. There's one more here. Should be okay now. Calling. So this internal function is actually meant to be down. So the same thing as before, except that we are using an internal function here. This internal function is what we are calling for the modifier up here. I need to just inside the modifier here. And because we are not making any state changes inside this internal function, we can restrict this to view. Yeah. So we can continue. Now is the time for us to deploy our contracts. But there are a few things we need. We need to supply some variables that will allow us to connect to the blockchain. So the first thing, I'm going to come here, right click and create a new file. And I'm going to call it .env. This file is where we are going to keep all our parameters, sensitive parameters to connect to the blockchain. So of course, I'm not going to show you guys this, but even as we progress, things like private key will be here, things like your API key from Alchemy or Infura will be here. I'm going to show you how to get those things, or even use publicly available RPCs. All right. So instead of which a major security practice you need to put in mind is that you don't show people your .env file, and if by any means you made a mistake to show it online, you should just believe that all the parameters there are compromised and find a way to change everything. All right, so instead of working inside .env file, I'm going to create a similar file that I'll be showing you, and it's going to be .env.example. So this is what I'm going to be showing you guys. All the parameter we need, I'll be putting them here, then I will show you guys. But the real thing will be here. It's just going to be the sample that will be here. All right. So let's get the RPC that will allow us to connect to the blockchain. So we're going to come to our browser here. Just search for chain list. All right. So chainlist.org, that's where we are going. All right. So these are the list of all the blockchains that we are interested in, that we may want to connect with. All right. So we are actually interested in Base Sepolia. Let me select testnet because we want to fork testnet. That's where we want to test on. All right, this is it. All right. Now it's showing us it's showing us all the publicly available JSON RPC node that we can connect to, that will help us to connect to the blockchain. All right. So we'll copy one of these for Base Sepolia testnet. Then as we are here, let's also do it for Arbitrum, since we are going to do also test on Arbitrum too. Arbitrum Sepolia. This is it. All right. These are publicly available nodes. So we'll copy one of them into our .env file. All right. So over here, we're going to paste for RPC for Base Sepolia and for Arbitrum Sepolia. These are the values we need. All right. Now we're going to create a file. You right click and create a file and name it make file. Now, as we progress, I'm going to explain what this make file will help us to do. Inside the make file here, you're going to paste include.env. So all we are saying to this make file is that it should include all the parameters we define here and make it available in our make file. So what does our make file do? If you look through the Foundry documentation, you notice that there are many long commands to run script to deploy your contracts. So instead of us having to copy those long scripts and running them on our terminal, we'll customize it. So we'll customize the command we are going to run. That's what Makefile will help us to do. All right. So I'm going to come here and I'm going to define command to start up our blockchain. So this is Anvil. So what this command do is that it just creates a copy of the live testnet and make it available for us to test. So things like our contracts, our across protocol contracts, Uniswap v3, Ethereum v2 will be available for us to interact with in our local blockchain. So for you to understand what I'm saying, if you want to start a local blockchain, you just need to run Anvil in Foundry. So you can see it's up and running, and it has given us 10 wallets, dummy wallets with 10,000 ETH to play with. Now we could test on this, but the problem is there's no across protocol, across contracts here. There's no Uniswap v3, there's no Ethereum v2 to interact with. So that's why we need to fork the mainnet. So if I want to do this now, to start this up, I will run make Anvil fork base, and this forks the test net, the base Sepolia test net. If I want to do for Arbitrum, I'll run make Anvil fork Arbitrum. All right. So that will be quite important. Now to close this, to stop the blockchain from running, on Mac OS, just press Ctrl C and it stops. All right. I'm not sure of Windows. Let me just clear my terminal. All right. Let's continue. Over here, we just come down here and declare it. All right. So I've declared for base and for Arbitrum. It's RPC URL, and this is our local host. This is where I got this one from. So if I come here now and I run make Anvil base, so you can see the port where it's listening from. That's where I got this from, 845. Then we need to declare this default Anvil key. We are going to be using the first private key here for that. So I'm using the private key of this dummy wallet to deploy. So I've just copied it, the private key here. So I'm going to come to our .env file and I'm going to paste it here. So let me copy the Anvil key here. This is the parameter we want to define. So yeah, this is okay. So after defining that, I think we have enough. We have enough to deploy our contracts now. Now our local blockchain is running, so I'm going to start open another terminal here. So I'm going to run make, and I'm going to deploy to running terminal. I'm going to run this command, deploy to fork base. So hopefully it runs. So I'm going to deploy now, and it's running. Everything seems to be okay so far. You can come to the blockchain and see how it's running. I think we have the transaction receipt. So it's been deployed, yes, successfully. It's success. So this is the contract address. So meaning that everything is okay with our contract so far. We've been able to deploy. Now the next thing is for us to interact with our deployed contracts. Let me just, because that will take us a bit of time. Let me just stop this from running. Okay. I'm going to minimize this, Command J. So I'm going to come here and create a new file, and I'm going to call it interaction with base contracts.s.so. Again, don't forget this .s.